Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into Tandem computer systems fault tolerance, a topic that's both fascinating and incredibly relevant even today. The paper we're discussing, Fault Tolerance in Tandem Computer Systems, details their approach from hardware to software. It's a classic in the field.
Absolutely. I've always been intrigued by how Tandem achieved such high availability. What were their core design principles?
The core was modularity, fail-fast design, and single fault tolerance. They broke everything down into small, independent modules. If a module failed, it would immediately stop, preventing cascading failures. And crucially, they designed redundancy so that a single failure wouldn't bring the whole system down. Ingenious, right?
Brilliant. How did they implement this at the hardware level?
Well, they used a loosely coupled multiprocessor architecture with dual paths everywhere. Think dual buses, dual ported controllers for peripherals, even dual power supplies in some cases. This dual pathing was key to their fault tolerance. They even had a hierarchical, fault-tolerant local network, which they called Dynabus, and later Fox, to connect multiple processors. Amazing scalability for its time.
And the processors themselves? Were they specially designed for fault tolerance?
Not drastically different from traditional processors, but with crucial differences. The Dynabus interfaces were engineered to prevent a single CPU failure from taking down both buses. They paid close attention to power management and error checking, using parity checks and other techniques to ensure fail-fast behavior. They also incorporated retry mechanisms in later processors like the VLX to reduce service costs, but availability wasn't dependent on instruction retry. Clever engineering to balance cost and reliability.
So, how did they handle software failures? Process pairs, right?
Exactly. Process pairs were their software equivalent of hardware redundancy. Each process had a backup running on a different processor. The primary process would send checkpoints to the backup, and if the primary failed, the backup would seamlessly take over. Initially, they sent full-state images, but later moved to more efficient delta updates and function calls. A very elegant solution to transient software errors.
That's impressive. But what about larger scale applications? How did they manage the complexity?
They introduced the concept of process server classes. A server class is a group of processes performing the same function, distributed across multiple processors. This allowed for load balancing and fault tolerance at a higher level. If one process or even a whole processor failed, the server class would continue operating using the remaining resources. A truly scalable architecture.
I see. So they essentially built fault tolerance into every layer, from hardware to applications. But wasn't there a cost associated with this?
Of course, there was a cost. Duplicating hardware and software adds expense. But they cleverly mitigated this by focusing on price performance. Their modular design allowed for incremental upgrades, and their architecture scaled linearly, meaning adding more processors proportionally increased performance. They also made innovations in disk technology, like the V8 and XL8 drives, to reduce storage costs. A remarkable balance of reliability and cost-effectiveness.
It sounds like their approach to operations and maintenance was also crucial to their success.
Absolutely. They minimized operator intervention by automating many tasks. The system would self-reconfigure after failures. They also developed sophisticated monitoring and diagnostic tools, including the CHECK system in the VLX, which used an expert system to analyze error logs and predict potential failures. Proactive maintenance was a key part of their strategy.
This is all incredibly insightful. It's clear that Tandem's approach to fault tolerance was groundbreaking and had a lasting impact on the industry. Their focus on modularity, redundancy, and proactive maintenance is still relevant today, a true testament to their foresight.
Precisely. And that's why this paper remains a valuable resource for anyone interested in building highly available systems. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the fascinating world of Tandem's fault-tolerant systems. Have a great day, and we'll see you next time.
Bye-bye.